Day 48 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. You know how we do. This time we're at day 48, guys. So if you're still with me, I'm glad you're still with me, guys, because we're all trying to build this Swift community together. We're all learning together. We're all helping each other out together, guys. And sometimes while you're learning, it's good to have people that you can ask questions or lean on to if you get stuck or don't know what you're doing. So that's part of what this page is about. It's bringing the Swift community together so that we could work together and learn together, and we could come together and do things that we might not be able to do by ourselves because we might have trouble understanding or whatever the problem may be, guys. So if you're still here with me, I'm glad you're still with me, guys, and I'm gonna keep bringing you these LeetCode problems every day. So now that I said that, guys, don't forget, guys, bring a mouse, bring a mouse, bring a mouse, bring a mouse right over here and click that subscribe button, guys. And then after you click that subscribe button, go ahead and hit that like button for me, guys. And then after you hit that like button, guys, go ahead, search through your emojis, find that bank emoji, all of my bankers out there, and go ahead and drop that bank emoji in the comments, guys, so we can run this engagement up and get this page popping like the Python pages are popping. You know what I'm saying? We gotta bring Swift. We gotta get Swift popping too, and get people excited about learning Swift, so Swift can grow. Swift, as long as Apple's here, Swift's gonna be here, guys. So that's something you should be excited about. We don't really have to worry about Swift going obsolete anytime soon because as long as Apple's around, Swift will be around. So I like to use that thought as motivation as to keep going, guys. So I hope you guys do too. Now let's look at the question we have. Today we have a question. We're still in LeetCode 75. It's an easy question. We're starting with the binary tree. We're starting the DFS binary tree part of LeetCode 75, question number 104, maximum depth of a binary tree. The difficulty level is easy, guys, so that's exciting because it's not going to be too hard, and the solution's easy to understand as well. The question's actually easy to understand, but if you're new to working with binary trees and things of that nature, then it might seem a little difficult, or it might be things you don't know that hopefully you'll learn in this video. So let's get started, guys. Question number 104, maximum depth of a binary tree. Difficulty level easy. You already know we're going to keep the solution easy and simple as possible. So question says, it says, given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So it's pretty self-explanatory. In example one, we have this binary tree. The input is the root equals 3, 9, 20, no, 15, 7. Those are all the values of all the nodes. The output is 3. So in case you're wondering how we got 3, we're trying to find the maximum depth, right? So you come down here, you start here, you got 1, 2, or it's 1, this counts, so it's 1, 2, and 3. So that's 3 values and that depth. To come over here, it's just 1 and 2, that's 2. So obviously 3 is bigger. However, guys, don't forget this one too. This counts. Even though it breaks off right here, this leaf right here still counts. All the leaves count. We're counting every leaf. So this one is 1. This is 1, 2, 3 as well, which is the same as this one, 1, 2, and 3. So these are both 3. But I say that to say, don't forget this one as well. It can go in this order. It doesn't have to be in a straight line. We're just counting all the leaves, and we want to find the maximum depth. And in this case, it's 3. That is why the output is 3. Let's look at example 2. They don't even show us the nodes for this one, but yeah, it's 1 node 2. The output is 2. Same reason the tree helps it a little easier to understand. So I don't know why they didn't put a tree here, but hey, we know what they're asking. And guess what, guys? We got a one-liner. The question is that simple. It's not that hard to understand. It's actually one line of code. I'm going to break it down to you so that it makes sense. But yeah, get excited about that. It's always fun to have one-liners. So first thing we're going to do, we're going to say root is equal to nil question mark 0. So with this right here, what this part does is we're going to see the root, if it's equal to nil or is it equal to 0. Does it have a value or is it nil and has no value? Excuse me, guys. If it is equal to nil, I'm sorry, guys, start that over. Root is equal to nil, question mark 0. So basically, if root equals nil, then we're going to return 0. This right here is kind of like a boolean. It's a boolean, so this is basically counts as a boolean. So if root equals nil is true, then we're going to return 0. If it's not true, that's when we put these colons right here. So if root equals nil, then we're going to return 0. Then we're going to say if it doesn't equal nil, that's what these colons are for. How are we going to handle it if it does not equal nil? And then this is how we're going to handle it. We're going to start with, we're going to say max. Then we're going to say max depth, root left, comma, max depth root, right. So and then we're going to come out here and we're going to say plus 1. So what this does is it's going to get us the max depth. This right here is going to give us the max depth of root left or root right. Whichever one is higher, that's what we're going to get. And then we're going to add 1 so it makes sure to count the node that we started with. But yeah, this is just going to go down to the left or to the right, and it's going to see which one is higher, which one is the most, or come down here and go to the left and the right, and it's going to add them all together, and it's going to find what the max depth is. It's that simple, guys. It's not even that hard. That's all the code that there is. So let's run it, or let's go through it one more time just in case you don't understand. Root equals nil. So this right here is basically if root equals nil. If root equals nil is true, then we're going to return 0. If root equals nil is false, then we're going to return the max depth of root left or root right, right? So if it equals nil, we're going to return 0. If it doesn't equal nil, then we're going to call this, and we're going to run this part right here, guys. So let's run it and see what happens. And it's accepted, guys. So let's submit it and see what that time is looking like. Boom, 7 milliseconds beats 93.92% of users with Swift, guys. It's not too bad, not too bad at all. One line of code. I'm glad we got through it. I hope to see you guys tomorrow because you know I'll be here. So I hope you will too for another day, another LeetCode problem. Until then, guys, I'll see you later. Peace.